DeepSeek Engram shows why AI scaling is no longer about bigger brains, but about smarter memory. This might be the most important architectural shift in AI since transformers themselves, a change that explains why today's models waste intelligence, burn compute, and still think slower than they should for years. The rule in AI was brutally simple. If you want a smarter model, you make it bigger. More parameters, more data, more compute. And for a while, that worked. Until it did in single quotes we hit a wall. Models got so massive that running them started to feel like powering a small city just to answer a single question. That's when the industry pulled out a cheat code, mixture of experts. Instead of using the entire brain for every sentence, the model only activates a few specialist parts at a time. Huge model, much lower compute per token. Problem solved. Or so everyone thought, because DeepSeek just dropped something that quietly exposes a much deeper inefficiency in how AI brains work. And once you see it, you can't unsee it. The problem isn't size anymore. The problem is memory. Even the best AI models today are doing something that would sound absurd if a human did it. They keep rederiving what they already know, over and over. Token by token, layer by layer. Let me make this concrete. When you read the phrase Alexander the Great, there is no reasoning chain firing in your head. You don't actively compute timelines, geography, or historical context. Recognition happens instantly. It's cached. It's automatic. It's cheap. Modern language models don't get that luxury, even if they've seen the phrase millions of times during training. Every time it appears in a new context, the model reconstructs its meaning from distributed representations. That reconstruction flows through attention through multiple layers, burning compute that adds zero new insight. Now multiply that cost by everything language repeats obsessively: people's names, place names, institutions, idioms, fixed phrases, boilerplate expressions, syntactic templates. The internet is not novel. It is repetitive. DeepSeek's core insight is uncomfortable. Transformers are wasting their intelligence budget on trivia-level reconstruction. That's the inefficiency Engram targets. Engram is not long-term memory in the sci-fi sense. It doesn't remember conversations. It doesn't reason. It doesn't plan. It recognizes specifically. It recognizes short, high-frequency word patterns. What older language modeling literature called engrams, 2 grams, 3 grams, compact linguistic chunks that appear endlessly across data instead of forcing the transformer to rebuild these chunks internally. DeepSeek adds a parallel memory pathway when the tokenizer emits a sequence that matches a stored pattern. Engram performs a direct lookup and retrieves a learned embedding for that pattern. This embedding is then offered to the main network as a candidate signal. The keyword is offered because raw memory is dangerous. If the model blindly injected retrieved embeddings, noise and collisions would destroy coherence. Similar phrases could overwrite meaning. Context could be corrupted. So Engram uses a gate for every retrieved memory. The model computes a relevant score between 0 and 1. High score? Memory flows in. Low score? Memory is suppressed. This makes Engram fundamentally different from external retrieval systems. It is internal, differentiable, and context-aware. At this point, the idea sounds elegant, but elegance doesn't matter. It doesn't scale. DeepSeek scales it aggressively. They keep the backbone identical to DeepSeek v3, a 30-layer transformer, 2,560 hidden dimension, 32 attention heads, mixture of experts routing, and a 128k token vocabulary. Training spans 260 to billion tokens. Then they ask the real architectural question. If total capacity is limited, how much should be reasoning specialists and how much should be memory? Their experiments show a sharp trade-off. All experts, no memory. Early layers burn capacity reconstructing patterns. Too much memory. Fewer experts, high-level reasoning. Degrades. The optimal regime consistently lands round, allocating roughly 1/5 to 1/4 of surplus parameters to memory. This leads to a surprising design decision. Instead of scaling expert count upward, DeepSeek removes experts. In the 270 parameter class. They reduce rooted experts from 70 to 255 and reallocate that space into Engram. The result is a model with the same compute budget, the same inference cost per token, but several billion parameters dedicated purely to memory. And the metrics respond immediately. Training loss drops. Validation loss drops. Generalization improves, but the real surprise shows up outside of pure knowledge benchmarks. Reasoning improves. Tasks like ARC challenge, BBH reading comprehension, math word problems, and even coding benchmarks all move upward. This seems counterintuitive until you look at where computation is being saved. In baseline transformers, early layers are overloaded with entity reconstruction and phrase normalization. Engram offloads that work, which means useful abstractions appear earlier in the network. DeepSeek verifies this with mechanistic analysis. Using CK similarity, they show that shallow Engram layers align with much deeper layers in the baseline model. In one case, layer 5 in Engram corresponds to layer 12 in the non-memory model. The network effectively becomes deeper without adding depth. Then comes the final question everyone asks: can this actually run? DeepSeek designed Engram for real systems. Memory access is deterministic, so it can be prefetched. They even offload massive Engram layers to CPU memory. The result? Inference slowdown stays under 3%. That's the quiet bombshell. You can bolt on absurd amounts of memory and barely pay for it. DeepSeek didn't make models bigger. They made them stop forgetting. Engram shows that the next leap in AI isn't just more parameters, more data, or more experts. It's removing an invisible tax that models have been paying on every single token. For years, transformers have been wasting depth, attention, and compute just to rediscover the obvious. Names they've seen millions of times. Phrases that never change. Patterns that should be instant. Engram turns those into memory. Fast memory. Gated memory. Scalable memory. And once that burden is lifted, something unexpected happens. Reasoning improves. Long context understanding improves. Coding improves. Math improves, not because the model thinks harder, but because it stops thinking about the wrong things. This is what real cognitive efficiency looks like, not a bigger brain, a brain that knows when to remember. If you want more AI breakthroughs explained clearly, aggressively, and without hype fluff, subscribe, drop a like, and I'll see you in the next one.